Hi, this is Sharon Sarago, today with exponents and radicals. When working with exponents, we need to remember that an exponent means repeated multiplication. So x to the fifth power is mathematical shorthand for x times x times x times x times x. In this example, the x is called the base, the number repeatedly multiplied by itself, and the 5 is the exponent. The format is base, and then the exponent would be this small stuff up here. In addition to the basic interpretation of exponents, there are 7 laws of exponents that you have to remember in order to solve problems on the SAT. If x is not equal to 0, then the following laws of exponents apply. If you have x to the 0, that's equal to 1. If you have xy to the power of z, that is the same thing as x to the z times y to the z. If you have x to the y times x to the z, that's the same thing as x to the y plus z. Now we have a rule here that says if the bases are equal and you're multiplying, then you add the exponents. You need to remember that. If the bases are equal and you're multiplying, you add the exponents. Then we have another one that says x to the y divided by x to the z, and it is equal to x to the y minus z. Our rule says if the bases are the same and you are dividing, you subtract the exponents. Again, if the bases are the same, the x, and you are dividing, you subtract the exponents. And then we have x to the y to the power of z. So these are just multiplied by each other, okay? So you have x to the y times z. X to the y, in parentheses, to the z power, is the same thing, just multiplying these exponents, x to the y, z. And then we have x to the negative y is the same thing as 1 over x to the y. And x to the y divided by z, this is a fraction, is the same thing as the z root of x to the y. Now, people, you have to know these backwards and forwards, because on the SAT, if they give you this in order to solve the problem, you're going to need to do this. If they give you this in order to solve the problem, you have to rewrite it like this. If they give it to you like this, you will have to rewrite it like this in order to solve the problem. They are going to test you of your knowledge of the law of exponents, and that's how they do it. So anytime you see one, you be prepared to write it in its equivocal form. This one is really a nice thing, because based on the 7th rule, a square root and all other radicals can be expressed with exponents. So anytime you see the square root of x, just remember that's x to the 1/2. Or conversely, if you see x to the 1/2, you remember that that's the square root of x. So if I had x to the 1/3, that would be the cubed root of x. And it goes all that same way through all fractions. Just remember this, x to the 1/2 is equal to the square root of x. Some of the problems you will encounter will be easily solved using algebra. So we're going to take a look at this next one. If we have x cubed plus 5 equals 3, what is the value of x? The first thing that we want to do is to isolate the x, get it on one side, get these integers all on the other side. And so we would subtract 5 from both sides. Then we, of course, would have, if we subtracted 5 from 13, we're going to get 8. 8 cubed is 8. And remember then, you would cancel this exponent by taking the cubed root of 8. And do you know what anything cubed is when it equals 8? Sure you do. 2 cubed is 8. 2 times 2 times 2. Other problems will ask for some variation of the information provided, but not necessarily what we typically think of as the solution. try to determine how the value you are looking for is different from the value you are given. For example, if you get x to the 6th power times y to the 4th power, and you know that equals 400, their question might be, what is the value of x cubed times y squared? In this problem, the exponent values have both been cut in half. You see the 6 divided by 2 for 3, the 4 divided by 2 there. So you would raise both sides of the original equation to a power of 1/2. So if we have 1/2 of these numbers, of course, you're going to get x to the 3rd, y to the 2, or y squared. But remember, whatever you do to one side of the equation, you have to do it to the other side. So simply by reducing those, we've also got to multiply this times 1/2. And remember that any time that you have an exponent of 1/2, that's really just a square root. Remember, we just looked at that. So 400 to the 1/2 is the square root of 400. And now I have x cubed times y squared is equal to 20. Another type of problem you might see involves variables as the exponent. For example, I might have 2x is equal to 2y. And then what do I know about x and y? They have to be equal since the bases on both sides are equal. So if I have 2 to the x is equal to 2 to the y, we have another rule that you need to remember, and it says if the bases are equal on both sides, then you can cancel them, and then you just calculate your exponents, and you would have x is equal to y. Let me say that again. If your bases are equal on both sides, you can cancel them, and then you just calculate the exponents. Here's another example. If 9 to the power of x equals 3 to the 5th times 3 to the y, what does x equal? And here are our choices. First, we need to get our bases the same. So we can rewrite 9 to the x as 3 squared for the 9 to the power of x. And now we've got our base 3 squared, and we've got our 3y there, all right? So we've got 3 squared x is equal to 3 to 5 plus y. All right, so you might be asking me, how come that's true? Well, look at this. We already took the 9 to the x, and we took the 9 and made it 3 squared. You're good there. And then we still have to have it to the x power. So we have 3 squared to the x, okay? And then we already had up here, that was equal to 3 to the 5th times 3 to the y. And remember the rule that said if your bases are equal, then you get to add the exponents when you're multiplying. If the bases are equal and you're multiplying, you can add the exponents. And so then down here, I get to take that base and I add my exponents, 5 plus y. Now I'm going to use the exponent properties to write each side of the equation as the expression with one base. And so I've got 3 squared, right? 3 to the 2x is equal to 3 to the 5 plus y. And then remember our rule, if the bases are the same, I can cancel them. And so then I get to manipulate just my exponents. 2x is equal to 5 plus y. Because if the bases are the same on each side of your equation, you can erase them. And so, of course, if I want to know x, I would just divide this by 2, also divide that by 2, and that would be my answer. Here's some practice problems. If we have the square root of 32 is equal to x squared times the square root of x, what is x? So I know a lot of you get really freaked out with square roots, but there's not really too much to be afraid of here. We have to simplify this, so what you're going to do is simply look for a perfect square within that. Well, there are a couple of ways you can look at it. One way would be 2 times 16, right? That's 32. And then here's my perfect square right here. So I'm going to rewrite that. It's the same. If I put 2 times 16 under the radical, it's the same thing by separating those into 2 different radicals. So the square root of 2 times the square root of 16. Well, remember, if you have the square root of 16, you know that that's 4. And so I would take that out. We always put our whole number on the outside and then our radical. And that would be 4 times the square root of 2. And that's what the square root of 32 equals. 2 times 16, break it up, separate this one, and it's a 4, and there's my answer. Do not be afraid of square roots. They're going to be your friends. Now, our question said, what is x? It didn't say this. They want to know what x is. So remember that they gave us x squared, this formula right here, x squared times the square root of x. So if I think that my square root right here is 2, right, for x, you see, I can test that because they gave me x squared right here, x squared, which would be 2 squared, yes, that does equal 4, times square root of x, it is the square root of 2. And so what's x? Clearly, it's 2. If 2 to the x is equal to 2 to the 3 minus y, which of the following statements must be true? All right, so there we have that problem again. And remember, if your bases are equal, what are you going to do? Cancel them. And then we just calculate x is equal to 3 minus y. All right, do I have anything like that? X is equal to 3 minus y. No, I don't. So I'm going to need to manipulate it again. So they do have a y here. Let's see what y is equal to. And take the 3, put it over there. And what do I get? X plus y is equal to 3. Okay? So it wasn't this one. It was way over here on this one. So anytime you come up with an answer like this, and you know it's true, you're going to have to look at your answer choices and see, well, how can I manipulate that so it looks like one of these answers? Okay, the problems that you're going to find on your exercises that you have are sometimes very straightforward and sometimes they are very difficult. So I just want you to remember that as you work through them, when you are given information about an exponent, be prepared to rewrite that in its equivalent form. And then you will be more likely to be able to solve the problem. Be sure to mark the ones that you have trouble with so that when we get together in our meetings this week, we can go over them. I hope you enjoy them. I love exponents and radicals. So I'll be talking to you in a couple of days at our meeting. Thanks. Bye-bye.